Good morning, good afternoon, good evening, across the country, around the world. Welcome back to the Kerbal Space Program. This should be episode 8. We've got some missions lined up, ready to go. So, equatorial orbit of Kerbin, I can do those off camera. Those are easy. But we have Moon Flyby, which is part of the SETI contracts. The probe, the Moon, low in space, run an experiment, which is great. Because we also want to position a satellite in a specific orbit, even though it's kind of high. But we'll go in, low flyby, and then pop it up into this orbit here. Probe, antenna power, margin, materials bay. So that's pretty easy, pretty straightforward and simple. We'll probably do this with a quad core, right? Because this doesn't care as long as there's some sort of science. And that's all it is, material bay. Awesome. And that's given us a chunk of money to start with. So we shall do that. Let's build a satellite that's going to go to the moon and stay in that orbit. So let's see. Let's check it out in Capcom because I'm sure it's going to give us some requirements. Orbit, materials bay. Yeah, Science Junior and Universal Storage. So we can't use a Science Junior Mini, which is a shame. But that's okay. Let's go with the SETI core because that's just a nice... It's a good core. It does a lot. Put that there, and then right underneath that, we're gonna get. Let's see. Do I have? There you are. Universal storage. Yeah. And then science. Immediately go with the science. Let's get magnetometer. I know it looks funny. Oh well. Orbital telescope. Nope, wrong one. It's Q. It's Q. You would think I would know that after all this time. Since it's pressure mat, too hot, and the Science Junior. So that will satisfy that requirement for the satellite in that specific orbit. After that, it's just about, what's it called? Just getting there. So, but there's support things we need besides just getting there. We're gonna need, there we are, some power. That'll be tons of power. Do we want, I think I do want underneath, because I don't have the big one yet, do I? I do not. So, whoops, wrong button. So underneath, I want to take all these guys apart. Okay, hold on. Underneath this, I do want a reaction wheel, just because it helps. And put you back in place as well. Awesome. So that reaction wheel will help with things. So we've got, right, that. Next, we're going to go ahead and put one of these big daddies on there because that'll give us tons of fuel. And with a Terrier, that should give us a few thousand delta V. Yeah, oh yeah, 4,500 vacuum delta V. So that's plenty to maneuver with. But we're not done with this yet. We need to add a few more things. Power. We're going to add a few... Oh, we're going to add 2 of these guys. Boop. And then antenna. We're going to add 2 of these guys. Q? Yes, it is Q. Boop. Awesome. And that's our satellite. So it's got a brain, some controls to it, there's science on it, it's power, fuel, and an engine, and can transmit and can generate power, which are some of the requirements. Yes? New unmanned probe with photovoltaic panels, with an antenna. That's the site, the Science Junior, and stability. So really, this is what we need to get to the moon. And this is tons of fuel. But we want to use all this once we're in orbit here. So we want the lower stage to have somewhere around 4,000 delta V. Who is this for, by the way? I want to name it. USI. Umbra Moon Sat. Umbra Moon Sat 1. Actually, do it with the I. There we go. Good. Good. So, that should satisfy all that. Below this, of course, we'll start with separators. Oh, not the big one. Sorry. There you are. Good. And then because this is kind of funny shaped, we're going to put a fairing on it. There we go. I wish I could keep it really, really narrow, but I can't. It has to flare out stupidly like that, doesn't it? That's kind of annoying. Oop. There we go. Just like that. Okay, good. That'll do. So, that separator is in the correct place. Yes, I've built these where the shield is between the separator and this, and yeah, it's bad. Anyway, so that's the satellite. Now to get it into orbit. Let's see if we do a couple of these guys with a swivel underneath. What's that? That's just enough to break the surface, but we're gonna want to go a little further than that. We don't have fuel lines yet, so we do not have that type of stuff yet, but it's okay. Otherwise we would do some asparagus staging, but we don't, so we can't. That's okay. We are gonna add stuff here. Basically do the same thing here. Come on, there you go. Get on there. Good. Then a couple more swivels. And of course, some, not wings, some aerodynamic nose cones. Boop. Good. Okay. So, those two stages light. That's a delta V, or a yes. And that's, well, thrust to weight is good because we won't be at surface level anymore. We'll be up higher. So that'll be good. That'll be enough to get us into orbit. Jesus, that's a lot of delta V. That's so much delta V, it's kind of ridiculous. Good. And because I want to be able to recover as much of this as possible, we're also going to put some radial chutes. Whoa, didn't want to grab that. On these guys. That way they recover, in theory. Do I have struts? I do have struts, so I can do that. Good. Because that's always a good thing to have. Right, so our satellite's up here, which by itself has tons of delta V. Oh, I saw this and thought 10,000 meters per second. Whoa, no, 7,000. That's still plenty. Even if we have to use some of this to get circularized here, it's plenty to get to the moon and circularize and fix the orbit there. I'm not worried about any of that at all. Okay, let's double check staging. Perish, no. I'll just put you up here with the fairing, because honestly, you'll break free before that anyway, so it doesn't matter. Those will disappear. Those separate, then we light that guy, yes. And then the fairing eventually separate, and the terrier. Good. That should be all we need. Let's go ahead and put some launch clamps on here, though. We'll actually put those in their own thing. Do like a proper rocket launch where we activate and then release. Okay. I think we'll be good. I think this will be enough. I think it'll be fine to get to the orbit of the moon. Umbra Moon Sat 1. Save. And launch. Do. Okay. Off. Reset and reset. I need to do those at some point. I think we're good. Yes. T and Z. Full throttle. And, here we go. Yes. Beautiful. Up, 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 and away. Once we get an upgrade to our fuel systems, we will start asparagus staging, and we'll have fuel coming, or this burning as well, but the fuel from these drained here, so this stays, quote, full. It's a neat little trick. But for the time being, this works just fine. Alright, so we're slowly accelerating. Not going quite as fast as I normally would like, or not accelerating as fast as I normally would like, but we'll be okay. Alright, there we go. 100, so start tipping over just a bit. That nose is a little bulbous, a little not wonderfully aerodynamic. That's okay, as long as we take things nice and gentle and keep it within the prograde marker. We should be okay. Alright, so we're just going to point prograde because we're going to burn out those two, the outer stages there in just a bit. There they go. And launch that one. So it's still climbing. We're actually going to just point where we are now. I don't want to tip over more. Otherwise, I worry that this won't be strong enough to actually get us up, 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 up. We just keel over. So there goes those two. There go those two guys. And hopefully, once we get to, yeah, once they drop below 2.5, they should recover. I should get that notice saying we recovered them soon. Yay. Alright, so this is a bit more of a vertical launch than normal, but this is a little bit underpowered. We're going a little slow. But that's okay. We'll still make it into orbit, I think. Maybe not. Our apoapsis is climbing, and our time to apoapsis is climbing, but not as quickly as I would like. Still another minute of fuel left on this, though, so that's good. This will just take a big burn once we get up to once we get up out of the atmosphere. Okay, let's go ahead and just turn it prograde now, though, just to get it. There we go. Okay, yes, we'll get into space. It'll be just fine. Whoa, okay, orbital prograde. That's good. Yes, yes, yes. I was like, why did it tip over like that? Oh, right. Another 25 seconds left of burn for these tanks. We're probably up high enough now that we can separate the fairing, so we'll go ahead and do that. Yes, not enough atmosphere up here to disturb this stuff. We'll definitely be leaving the atmosphere. So let's go ahead. Well, we'll just burn out this stage. Done. Kill the throttle. Separate. And activate that engine. We're going to leave it off for now. So we are about to exit the atmosphere. There we are. We are out of the atmosphere. We have a pretty high apoapsis. But that's okay. We can add maneuver and do this. So this, I was a bit, it's not, this didn't work out quite as well as I would have liked, but it's okay. This is going to take, what, 1200. Still, we'll have plenty of delta V left. So that's going to be 97-second burn. We hit that node in 2 minutes. So that's going to be, oh gosh, about 45, 46 seconds ahead, I think. Yes. I don't know why they don't just go as a... I think it's because of the antennas I put on there. Annoying. But we can go ahead and extend the solar panels. Extend the antenna. Extend the antenna. And extend the solar panels. Good. So, yeah, at about, I think, like 47 seconds or so, we should get that. We'll get the countdown on the better burn time thing here as well. Ah, there it is. If we just basically push prograde, we should be okay. But it will take a while. Terriers are fairly efficient, but they don't have a very high thrust to weight. They're kind of weak. But for what we're doing, it'll give us plenty. I think, I hope, I pray. I'm pretty sure. So we are... Yeah, our time of apoapsis is slowly dropping. But that should slow down as we push the apoapsis away. Yeah, this will be fine. It'll be just fine and dandy. So technically, to get this correct, though, I should be pointing at the node instead of just prograde. I admit I was being a little lazy. It'll be a little more efficient, a little more optimal to actually burn toward the node. In theory, although now it's pointing us somewhat below the horizon. So we're about to pass our apoapsis in about 15 seconds, 13. But again, that's okay. We'll be into an orbit by then, and our apoapsis is pretty darn high. So we'll drop back down a smidgen. Yeah, so I hit the node a little late because I was time warping. Oopsie. Okay, so let's see. Periapsis is out of the ground. Camera change, wibble wobble, and we are orbital. Don't have to worry about falling back into the planet. Still have 3,025 meters per second of delta V. Awesome. So, next. Oh yeah, so we're in orbit. We've done that a few times. That's doable. Next, we're going to go to the moon. The moon. Set as target. So, a launch is oftentimes not all that wonderfully equatorial. We got it. We're within a degree. So that's pretty good. Oh man, those marks are just kind of annoying. I can't get rid of those, can I? Oop, come back. No, there's no way to get rid of those thingies in space. Pity. Anyway, we're going to the moon. So how do we get there? Well, the way to do it is... the trick I learned from Quill 18 is if you are actually in orbit around Kerbin, when the moon rises, boop, burn toward it. So the moon's going to rotate a little bit. That'll be somewhere like right here-ish. Now that we have maneuver planning and patched conics, we can actually see it. This will actually show us, aha, our Munar encounter. There we have it. We try to do it with as little fuss as possible, or as little delta V as possible when we make changes. So that's 835.7. And then we can also focus the view on the moon. Come on, don't crash. And we can see where our orbit takes us. Oh, beautifully near the orbit that it wants us to be in. So that, I will take that. This maneuver we will take. Do I have? I don't have that yet. I have to do it myself. Dang it. Otherwise, Maneuver Planner would let you just tell it to do it, and it does it. So, we are going to quick save. Good. And that was a complete prograde burn. So we're just going to set to prograde. It's going to rotate around anyway, but... Alright, we can warp to the next maneuver. Do. So, when you're planning these... Kerbin, moon, burning here, and it should intercept about there. Or maybe it's here and there. Anyway, when the moon rises, you do it. There's probably a slightly more optimal place and time to do this, but it's going to work for us. Because we're probably going to... Yeah, there, the moon rose. So we're a little behind the curve there, according to Quill 18's method. 48 seconds. Oh, yeah, that's about right. Okay, let's time warp a little bit more. And 3, 2, 1, burn. And we're honestly just pointing prograde because that's where the maneuver was. And we can watch our orbit grow and grow and grow. And for a moon encounter, this is fine to go to the moon. For an actual landing, I would go to Minmus first. It's lighter, or the gravity there is lighter, and it's not that much more delta V to get from the moon to Minmus, or past the moon to Minmus. But the gravity on Minmus is much more forgiving, so it's much easier. Okay, so that's gonna start growing really fast. We want to slow it down. Slow down the burn. Slow down the burn. There we go. Okay, so we have an encounter with the moon. And again, we can take a look and see what that looks like. That's not bad. I will take that, and then we can fine-tune that later. We're up fairly high. We can fine-tune that on the way. Good, so we have our encounter. Quick save. Quick saving. Awesome. And then we can warp here out a ways, an hour or so into the future. Oh, okay, so we're there. So we're here. So this could come in a little closer. Whoops. But I don't really think it's necessary. let's see. If we burn a little bit, I think that would be radial in. And actually, for little changes here, we're going to do a trick, a technique rather. We are going to reduce the power on this guy by a lot to 6. That's fine. That gives us very, very fine-tuned control. So we're going to point radial in, and we're going to see what this does. And that's the wrong one. That rises it. Rises it, raises it. So we're going to go radial out then. Which is also burning toward the target. Okay. There we go. So we're going to lower it down to something in this neighborhood. But barely using any fuel. Small changes way out here make big changes further down the line. And I'm not sure if this is the most optimal place to do this or not, but it's going to help. Honestly, we're way high. We could go way lower and we'd be fine. We might dip down pretty close to get that low orbit stuff, which actually the mission requires. What is this? Oh yeah, that was our other stage. I didn't require it. Oh, what happened to the other two? That's lame. Anyway, we're going to pull this just inside of the blue circle here. Maybe a little more than just inside, but inside. That'll do. Okay. Now we go back out to the engine and unlimit it, because otherwise, if I try to do things, it would be bad. All right, so we are on our way to the moon. We're going to warp up to the sphere of influence change, our moon encounter there. Backspace. So you want to be careful when you come up on sphere of influence changes. I've seen it before. I've done it before, where you time warp past it and you slingshot around. It does weird things sometimes. So you don't want to go any faster than, well, I mean, you can go kind of as fast as you want. It should slow you down to 50 times as you pass. There it is. And then once you're there, you want to, double check it and slow down. Awesome. So we are now in the moon's sphere of influence. Yay. Flyby of the moon. Gravitational influence. We've escaped the gravitational influence of Kerbin. Yes. In the game, yes. So here, at maneuver, retrograde to get ourselves into an orbit. And how much is that? Not much at all. We want to get into a low, fairly low orbit. I'm not sure what low consists of. We're going to go for about, 20 something. 13. That's fine. Good. And that's going to be a retrograde burn coming up in a few minutes. In an hour and 42 minutes. Okay. Oh yeah, and here we are over the moon. Yay, yay. So we've got this burn, 14-second burn, coming up in 45 seconds or so. We're gonna warp just a little more, because otherwise it would just take too much time. Orbital period infinite. That's fun. Oop, there we go. Sorry. I was distracted for a second there. It's okay. We should still be just fine. We're going to switch back to map mode, though. So we are now in an orbit around the moon. But I wanted to get it nice and low. And I wasn't even watching that. I eyeballed that, and I was within 1 meter per second. Awesome. So, there we are. Another world's first. Entered orbit of the moon. But to satisfy the mission, we have to be low in space and do that. So we're gonna time warp until we have orbited around to our low in space position. And then we'll do the science. Eek! Come on. There's us. And there's the moon. Wow, it looks really close. Alright. Science. Do all the science. You're not going to do the science? Oh, because I have no connection. Of course. Okay, so then we have to... I'm like, why is nothing available? Why can I do nothing? Right, because our signal is blocked. Doi. There it is, red right there. No probe control. That's fine, and that's a setting I set to make things a little bit harder. That's fine. We will time warp until we have control. Which should be about now. Yes, we get a little bit of the occlusion through the moon. There we go. All the science. Whew. All the science. All right. Yes. Transmit. Just watching our power consumption. Not that any of these are huge. Transmit. Transmit. Yes, I know. Okay. And lastly, transmit the magnetometer scan. Oh, right. Orbital telescope, because it's biome, it'll keep doing different ones. And we are, of course, on the dark side of the moon, so all this science, or all these transmissions are not getting replenished. So what do we got? First scientific data from around the moon, and we've completed the moon flyby. So that's the SETI contract that we have. Next, we will line this guy up with the orbit that they want us in, which is a simple thing, kind of like what we did before, where we change the angles and make it match with the the collinear orbit. Sure, transmit that. Those aren't that big. Okay, they're kind of big. Where is the sun? Of course, we were totally on the dark side of the moon. Oop. So we're gonna time warp. There's 4. Oh, space high over the moon. Right. We're gonna keep for the moment, because I want to get to power. I need some power. Where is the sun? There's the sun, and there's all the power. Okay, good. So now we can transmit these things again, though. Review data. Transmit. Orbital. View data. Transmit that as well. What else did we have here? Nope. View data. Transmit that. Nope. And then... Nope, there was a 4th one. I just don't know where it is. Pity. Huh. No. Those are good. Orbital telescope's good. That I can't do anything else with. I felt like there was 4, and I can't find it. Oh, that's too bad. Alright, anyway. So there we are in orbit around the moon. Now it is time to fix things and get us lined up into this orbit. We're going in the correct direction, which is a bonus. Sometimes I miss that and I don't check for it. We are, so that's good. We're going to have to do stuff here because over here we're kind of blocked. So here we'll go ahead and raise the periapsis and possibly adjust our inclination as well. Maybe not on this go round, but soon. Yes. Yes. So apoapsis, add maneuver. This makes this type of stuff much easier because you can actually see what's happening. You can't lock to anything, but you can make changes. And because we have this here, we can do this, and it'll get us closer. Oh, it doesn't show the perspective ascending node, does it? No. Okay, so let's cancel that. Although that's not very much. Yeah, let's do that. That gets us a lot closer to our orbit. So I'm gonna say let's do that, just because that seems about right. It's only a 5-second burn coming up in a bit. And now we do need to point toward the maneuver node because it's a maneuver that's not in just one plane. Good. We're gonna quick save real quick before we do this, just because. Oh, it's coming up in 44 minutes. Okay, hold on. Let's warp to next move. I'm like, why is this taking so long? Oh, right, because I'm not anywhere near it. Okay, good. A minute left. Okay. So we're more or less pointing at the node. Okay, good. So that's good. Our periapses and apoapses are actually pretty darn close to where... Oh, well, they're close to that. They're not insanely close to what we want, but they're decent. So we are 7 degrees off. That's fine. We're going to warp to about here and correct our inclination. We are going to again... We're going to again point anti-normal. Because we want to turn down through the ascending node. You can see that node moving around. Whoop. Da-da-ba-da-ba-da. It went away. It went away. So I don't touch anything until it shows that it has maintained stability for 10 seconds. There it is. It felt like a long 10 seconds. Awesome. We've successfully deployed our satellite in orbit of the moon. And we're done. No other corrections or anything like that are necessary. We're good. We're done. That's it. Ta-da! And I think we've run all the experiments on this guy that we can. I'm going to stow this just because it's the magnetometer sticking way out like that. It's just annoying. The orbital telescope. Log. Visual. High in space. Okay. When we were low in space, it gave us multiple things because they were biospecific. But high in space, it doesn't care. And there we have it. A satellite into what we did the Moon Flyby, which was a SETI contract, as well as putting the satellite into a specific orbit of the moon. Let's go back to the Space Center and check out mission control and see what's next. So yes, we did the Moon Flyby. Oh, geez. Flyby. Carbon-powered landing. Oh, we have to do a powered landing. Right. Remote powered landing near the black monolith to the north after reaching 500 meters altitude. No parachutes, wings, or even nose cones. And no air-breathing engines. Very light lander. Landing legs, Oscar, and LV-1R engines. So that'll be something to try next. But we also have a few others. Let's see. Satellites. Polar. Equatorial. I already have those. Specific orbit of the moon. Minmus, moon. Those are easy to do. Depending on what their orbits are. Ooh, like some that are like this, 90 degrees. That's pretty nice because that's at an angle. So that'll give you good radio coverage, but not right now. Part testing? No. Collect science. From space around the moon. Again, we have a satellite that's there, so let's do it. Moonsat 1, fly. Oh yeah, you can see all those circles for satellites for the moon, which we can do. That's easy, or I can do. That's easy enough to do, but that's kind of grinding without actually doing much. Spheric pressure scan, sure. Transmit. And transmit. And I think transmitting those two completed that mission. So I just got 40,000 almost for doing nothing, which is great. Ugh. So that's great. That's amazing. That's awesome. But next episode for you guys, for what I will record for all of you, will be the... yeah, it will be the powered landing. What's this? Minmus and Kerbal. Minmus and then from high above Kerbal. So I need to do a slingshot past Minmus at low space, and then once I've escaped Kerbin's sphere of influence. And that's a decent... It's okay, but that's just a probe. Really simple. with like one tiny experiment on it. So that'll be fun too. And a manned orbit and safe return. Yeah, so that's cool. So that's a manned orbit. I don't know if I've done... I don't think I've done a manned orbit yet. Everything's been unmanned first. But we'll do that too. Anyway, but the powered landing, we'll take that. What do we have? 3. Take this. I'll take that. And then I'm gonna take... Go away. What do I have? I have room for... Oh, yeah. Yeah, I'm going to take these satellites as well because they're pretty easy. I'm actually going to knock out all these satellite missions here off camera. And that should raise our fundage up quite a bit. Take that one. I'll take this one. And I'll take this one. Satellite missions are bread and butter. They get you a fair amount with some decent advances. They're really easy to do. Oh, those are already circled active because they were already here, I think. But... yeah, satellite. That's easy peasy, lemon squeezy. I will do those, like I said, off camera. We got some science to spend. We'll take care of that next time as well. That's it for this episode, though. Thanks for watching. Thanks for hanging out. If you like, hit subscribe. Tell your friends, tell your neighbors, pass the word. I will catch you later.